what is actually happening to the climate is not what the public is being led to believe. Okay, episode 1 was all about how the world got headed in the wrong direction. It was nobody's fault. Nobody tried to deceive the public. Nobody did anything. We just had the scientists explaining the problem in a scientific manner, which is exactly what you would expect. Now I'm going to introduce a more practical approach. Episode 2 shows the graph that helped me to understand what is actually happening to the climate and why scientists have difficulty seeing it. Please pay close attention from this point forward. What is actually happening to the climate is not what the public is being led to believe. For the past 36 years, we've been headed in the wrong direction. And because we made climate change seem less onerous, less immediate, which gave the climate change deniers all the room they needed to come in and start saying, no, it's not really happening, don't worry about it. The oil companies published papers to try and confuse the public. And as a result, the public was confused, including myself. And so we more or less turned our back on the situation and went about our lives. That is the tragic irony of what happened because climate change was explained to us, not in the wrong way, but it was explained to us by scientists. And scientists look at the problem differently than I do. I'm basically an economist. Let me move this over here. Because the public is not being told the truth, this is a major problem for our civilization and our species. Okay, this is the graph, the picture, or whatever you want to call it, that finally opened my eyes. I've looked at this many times without seeing anything. And one day I was staring at it, not knowing what I was looking at, when something occurred to me. And by the way, there are many other organizations that have this same type of graph, but they have lots more information, and there's all sorts of lines going everywhere, and it's a complicated mess. I like this one because it's simple. They've taken out all the noise, and you get the general outline here. So when I'm looking at this, I see this line flatten out all along the top. This bump is the Permian mass extinction. But other than that, this is the steady state. This is where the Earth's climate likes to stay. In order for it to get out of that state, there has to be what they call a perturbation. You got to perturb, you got to piss off the climate, and then it changes. These perturbations have happened throughout history. But the one that we took place now began 50 million years ago, and it happened slowly. And that was called photosynthesis. And photosynthesis pulled the carbon out of the atmosphere and converted it to fossil fuels. Some of it, a very small portion of it, was converted to fossil fuels. That reduced the amount of carbon in the atmosphere, and the Earth began to cool. And then I began thinking, well, if there are 3 reservoirs for the carbon to be in, there's the Earth, there's the oceans, and there's the atmosphere. So that's where all the carbon is, and the carbon moves between these 3 things, and that's called organic chemistry or the carbon cycle, and that's what the PhD study, and thank goodness they do, and they keep us appraised of what's going on with the carbon. But I looked at it a different way. I think there's a 4th chamber for the carbon, and that's called fossil fuels, because you see, fossil fuels are carbon that is no longer in the carbon cycle. In other words, fossil fuels don't, juxtapose and go into the atmosphere again or go into the ocean again. No, they just sit there. They're stored energy. They're fossilized sunshine. Free energy for us to use, right? And it could have been very helpful. We could have used it in a sparing manner, but we didn't because we didn't understand. So now if you got those 3 reservoirs, plus the 4th one is the storage, then I began to think then, you can't put all of the carbon into any one section, can you? So it's got to maintain a balance. Even though the carbon's moving around, a balance has to be maintained. So I thought to myself, well, the reason that graph flattens out, that's because when all the carbon that is available to go into the atmosphere is in the atmosphere, then obviously that's as hot as the Earth can get. You can't have a roaring campfire if you only have 3 logs. You need to have more fuel. Well, carbon is the fuel that heats the Earth. So I began to think of that. And then I began to think of, well, if that's the case, and that's it, and I know from common sense that the relationship between the amount of carbon in the atmosphere and the Earth's temperature has to vary on a linear basis. This is the one big problem we've got to get over. Now, I know it happened. I know this is true. Anybody knows it was true. If you bake a cake, you put in 1 cup of sugar, it's going to be a certain taste to it. You put in 2 cups of sugar, it's going to have a sweeter taste. So I know there has to be this relationship between carbon and temperature. There is no other variable that matters. We also know the pre-industrial temperature and carbon concentration was 56 degrees Fahrenheit and 285 parts per million of carbon. Or another way of looking at it, which is easier to understand in my opinion, is for every 10,000 molecules of air, 10,000 molecules of air, there are less than 3 molecules of CO2 in the atmosphere, or CO2 and methane combined. But anyway, just think of it that way. Just think of 10,000 molecules of air, and you've only got less than 3 of carbon, and that's enough to keep our planet warm, blue, green, livable. The climate calmed down, the weather becomes predictable, agriculture evolves. After agriculture comes civilization, and then towns and villages and the megalopolis of New York and Los Angeles and Tokyo. That's all because of agriculture, and agriculture is here only because the climate calmed down and the weather became predictable. So this is what I knew. So then I said to myself, scientists say the Earth was 77 degrees. Okay, I'll buy that. Maybe it was, maybe it wasn't. But if it was 77, then I know exactly how much carbon had to be in the atmosphere at that time. So if I know how much carbon was in the atmosphere 50 million years ago, and I know how much carbon was in the atmosphere pre-industrial, and I know how much carbon we've put back in the air, because this can be measured, then I know exactly how hot our Earth is going to become. And that is the purpose of this presentation. I figured that out. We haven't been looking at it the right way. But I was still a little uncertain of myself because I'm not a scientist. So I looked up the lead author on the report that produced this graph, and I was able to get him after about 6 months to talk to me on the phone. And we had a very pleasant conversation. And then when the conversation was over, I said, oh, one more thing, Professor. Here's what I think. And I told him about my theory of the reason that the Earth temperature levels off it, because we got all the logs are on the fire. There's no more carbon to go into the atmosphere. Now, I wasn't positive about what I was talking about, so my heart was in my throat when I posed this question, because I was pretty much sure he was going to come up with something that scientists know and I don't. But instead, he thought about it about a microsecond, and he said, never thought of it that way. Makes sense. Well, I let out a sigh of relief that would have blown out a house fire. Really? Oh, whoa. But the important part about that, what I learned the most from that statement was not that it makes sense, because I already knew that it makes sense. It's when he said, never thought of it that way. Quote, never thought of it that way. He's a scientist. That's not how scientists think of the problem. So I came in as an economist, and I explained it to him in a very simple way. And he didn't blow me out of the water. He just said, makes sense. Now, let me just forget, the one other thing I need to determine is I would like some scientists to tell me, yes, there is a linear relationship. And this is where they stumble. They don't think of it that way. So I had to confirm. So I managed to get a few scientists on the phone. I don't want to bore you, but I think this is worth understanding, that scientists just don't get it, or they don't see it the same way I did. Never thought of it that way. Well, here's another one who never thought of it that way. Dr. Ronnie Avasar, University of Miami. We were in a video call, and I tried to tell him that there's a linear relationship. He waved me off. Literally, you could see his hands waving in the air there. No, 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 no. It's not linear. It is something else. And he told me all these things that were going on. He's 100% correct. I wouldn't dare question his knowledge of climate change. But he isn't looking at it the right way. Alan Robach at Rutgers, he was even worse. He yelled at me over the phone. He said, no, he said, it's not linear, it's logarithmic. And that was the end of the call. Well, he's right. The professor is correct. The relationship between carbon and temperature is logarithmic, but only after the Industrial Revolution. It's logarithmic because we're forcing so much carbon into the air, every molecule can't be the same. They vary on a logarithmic basis, whatever that means. So I was stunned, and I ended the call, and afterwards I said, well, wait a minute. I'm not talking about after the Industrial Revolution. I'm talking about before. Couldn't get him back on the phone, wouldn't answer my email. They're all the same. This guy, Peter Thornton, he's at Oak Ridge. That's where they invented the atomic bomb. Well, those guys down there, I'm telling you, they're puffed up like pigeons. They know more than anybody will ever know. And lucky I got him on the phone. He said, send me your paper. And in my paper, I explained to him that the amount of carbon in the atmosphere, carbon dioxide in the atmosphere, was twice as much as was being reported by NOAA and the Scripps Institute, which is at 13,700 feet. And he wrote back and he said, the fact that you think that you know that there's more carbon in the air, twice as much carbon in the air as is being reported by Mauna Loa, is unconvincing. He was being polite. But he didn't see what I see. He's only looking at what they're measuring up there. Now, why are they measuring it up there? They built that thing up on Mauna Loa because it's so much higher in the air and it's out in the middle of the Pacific, they can get good data. And scientists love nothing better than good data. So I had no more conversations with him, but I'll explain to you in one of the episodes why there is twice as much. Christopher Guy said to me, he wrote me an email and said, I don't know if there's a linear relationship. And he's a great guy and nice to talk to. He's also teaching science, and he didn't see what I see because he's a scientist. And Dr. Ann Toomey from PACE wrote me a wonderful email. That they wouldn't see me, they wouldn't talk to me, they wouldn't consider my PowerPoint. But she wrote me a lovely letter and said how important it was that citizens like myself, that, we're doing the best we can to understand climate change, how great it was. But, she said, I'm a teacher, and I feel obliged to give my students some level of hope about what lies forward in the future. I don't want to send them off into the world thinking dark thoughts. Well, I can't say I blame her. She's a woman. But the fact of the matter is that's fraudulent. You can't let your students go off into the world without telling them what's going on. This guy, Dr. Hart, I had an hour and a half long video call with him, but he was not a scientist. Dr. Hart is an economist, a PhD in economist, worked for the Department of Commerce, and his thesis had to do with climate change. Is it feasible to suck the carbon out of the atmosphere? Is that economically feasible to suck the carbon out of the atmosphere? And is it scientifically possible? Well, he wrote this thesis back in the mid-90s, and he came to the correct conclusion back then, which is no, it's not scientifically possible, and no, it's not economic to do it. This last fella here, this is the one that finally saved me. The reason I got him to talk to me, Nicholas O'Mara, he's at the Lamont Doherty Earth Observatory, was I wrote him, and I pretended to be, I don't like to be fraudulent, but I probably should have used this approach long ago. I wrote to him and said, I'm a single mother, I have a teenage son, and he's asking me questions I can't answer. Please, Dr. O'Mara, can you tell me, is there a linear relationship between carbon and in the atmosphere and the Earth's temperature? And he wrote back directly with a ream of information and links and other pages to read and stuff like that. All I was interested in was the first line of his email. And he said, yes, there is a linear relationship between the concentration of atmospheric carbon and the Earth's ambient temperature. Beautiful. Beautiful. So now at least I knew that much, so I could go on from there. This is the end of episode 2. In episode 3, I'll explain what the carbon ratio is and why it's the sole reason the earth is heating up. Tune in.